Okay, so here's a little explanation about odd and even functions. First of all, let's talk about odd functions. The graphical way we can tell if our function is odd is it should have what's called rotational symmetry about the origin. If you think about the word rotational, it pretty much means what it sounds like. If I spin this graph 180 degrees, does it look the same as the original? So here we have a cubic function. You can see that if I turn my paper upside down, the graph looks exactly the same as the original cubic function we started with, and I spun it 180 degrees. So a cubic function is odd because it has rotational symmetry about the origin. Now, algebraically, how can we tell if a function is odd? Well, the test we have using algebra is that if I test negative x, if I plug in negative x into the function, is my resulting function the opposite sign of the original, and it has to be the entire function that we started with. So, for example, again, in my cubic function, if I sub in negative x into x cubed, what happens when it comes out the other side? It comes out as a negative y value. And if you want a concrete example of this, if we take negative 2 and we cube it, negative 2 times negative 2 times negative 2, we get negative 8 as an answer. So our negative input that we put in comes out with a sign that has the opposite of the original function, which was x cubed. So that's a test to see algebraically if we have an odd function. Next up we have even functions. They're a little bit different. An even function has symmetry about the y-axis. So the easiest way to think of this is almost like a mirror, or you think about folding your paper in half lengthwise. Does the graph look the same on both halves? And it does. You can tell that if you fold this paper in half like this, we can see the same image on the other side of the y-axis. So this is an even function. That's graphically. Algebraically, we do the same test. We take a negative x and we plug that into the function, but this time, to see whether or not it's an even function, it should come out looking exactly the same as the original function we started with. So again, using this equation here for our absolute value function, if I test negative x in the equation, what does an absolute value do to a number? It makes it positive. It comes out as positive x. And notice that matches exactly what the original function would do, which is come out as a positive x. Okay? So this is a test to see that we have an even function. Now, sometimes we don't have an odd or an even function. And in this case, y equals x minus 3. It is linear. You can see that. But notice, first of all, if I turn my page upside down, it does not look the same as the original. This looks like it has an intercept here at positive 3. But my original graph has an intercept down here at negative 3. And certainly if I fold the page in half, I don't see the same image coming up reflected on the other side of the y-axis. It's not odd and it's not even. If you were going to test it algebraically, we'd take negative x and we'd plug it into this function here, and out the other side you would get negative x minus 3. And you might think, well, that's the opposite of this equation. But really, the opposite, if we wanted an odd function, would have to have everything the opposite, not just the sign in front of x. So an odd function would have had to come out negative x plus 3. You would have to reverse both of those operations for it to be odd. That didn't happen here. So this is neither odd nor even. It's an example of neither one of those functions.